Hi everybody, happy Monday. Welcome to our next lesson on trigonometry. We're on day 3, and today we're gonna be talking about word problems when it comes to trig. In the word problems that we're gonna be taking a look at today, we are gonna see two different phrases that we're gonna have to know what they mean. Angles of elevation and angles of depression. So angles of elevation are angles measured between lines of sight and a horizontal line when you or someone in the word problem is looking up at an object. An angle of depression is an angle measured with your line of sight and a horizontal line when you're looking down at an object. So if we take a look at this diagram here, we have a dog on the ground and we have a bird up in a tree. So the dog on the ground, if he wants to look at the bird, he's going to have to look up. So he would be looking up at an angle of elevation. The angle of elevation is measured with the dog's line of sight. This line would be the line of sight, measured from that line of sight to a horizontal line. So if the dog were looking straight ahead. So angles of elevation are measured up versus angles of depression. So the bird looking at the dog, this would be its line of sight, looking at the dog's eyes. The angle of depression is measured down from a horizontal. So in the word problems we're going to be taking a look at, for some of them we're going to have to draw our own pictures. So again, you want to make sure that angles of elevation and depression are drawn and measured either up or down from a horizontal line. Since all horizontal lines are parallel, this angle and this angle, remember they form like this Z shape, would be congruent because they're alternate interior angles. So in the next problem, it says, in the diagram below, identify each of the numbered angles as an angle of elevation or as an angle of depression. So we have a couple pictures here and we have numbered angles. So the first angle I want us to figure out what it is angle 1, which is right here. And angle 1, if we find like the diagonal part of the angle and the horizontal line, so this is measured up. The diagonal part of the angle is above the horizontal line, and that's where 1 is being labeled. So this would be an angle of elevation. Number 2, if we find the diagonal part of the angle, it is below the horizontal line that makes up the other part of angle 2. So angle 2 is drawn down from a horizontal. So 2 would be an angle of depression. Let's find number 3 in the picture. Number 3, if we find the diagonal part of the angle, it is above the horizontal part of the angle. So it is drawn up from a horizontal. So this would be an angle of elevation. And lastly, for this diagram on the left, angle 4, the diagonal part of the angle is below the horizontal part of the angle. So it means angle 4 is drawn down from a horizontal. So this would be an angle of depression. For the next picture on the right, we want to find angle 5 first. So angle 5 is right here. Again, the diagonal part of the angle is above the horizontal part of the angle. So angle 5 is drawn up from the horizontal. So this would be an angle of elevation, as would angle 6. It's situated the same way. The diagonal part of angle 6 is above the horizontal part. So this would also be an angle of elevation. Let's find angle 7. Angle 7 is here. The diagonal part of the angle is below the horizontal part of the angle. So angle 7 is drawn down from a horizontal. So this would be an angle of depression. Let's find angle 8. Angle 8 is spanning like from this horizontal all the way to this diagonal part. So angle 8 kind of encompasses angle 7. Angle 7 is inside angle 8, but angle 8 is larger than angle 7. Again, angle 8 is drawn down from a horizontal because the diagonal part is below the horizontal part of the angle. So this would also be an angle of depression. So that was just an example there to go through kind of how to identify if we have an angle of elevation or an angle of depression. What we're going to get into now are some word problems. So the next word problem says that you are 50 feet from the screen at a drive-in movie. Your eye is on a horizontal line with the bottom of the screen, and the angle of elevation to the top of the screen is 58 degrees. How tall is the screen? So in this one, we have a picture drawn for us. We want to know how tall the screen is. So we need to figure out what side length of the triangle are we trying to find. If we're at a drive-in movie theater, would this diagonal segment be the screen, or would this vertical length be the screen? Well, it would be this vertical segment that I want to find the length of. So I'm going to label that with an X. 58 degrees was already labeled here up from the horizontal as the angle of elevation. So I need to set up sine, cosine, or tangent in order to figure out the value of X. So in relation to this acute angle I'm given, I'm going to look at the side length I'm given. Is this side length the adjacent leg, the opposite leg, or the hypotenuse of the right triangle? We can assume the right angle is here. 50 would be the adjacent leg. What is the length I want to find? Is that the adjacent leg, the opposite leg, or the hypotenuse? It's the leg across from the 58-degree angle, so it's the opposite leg. So if we think about SOHCAHTOA, which trig ratio has O and A in it? Well, that's going to be tangent. So I'm going to set up the tangent of the acute angle. I like to write it as a proportion, so I put that over 1. Tangent is equal to opposite leg length, which is X, over adjacent leg length, which is 50. Once I have the proportion set up, I go ahead and cross multiply. So my first cross product will get me X. My second cross product will get me 50 times the tangent of 58. Remember, I always like to write the coefficient in front of the trig ratio because it's easier to put into the calculator that way. And there's less error when putting that into the calculator. So we do need to have a scientific or graphing calculator in order to figure out what the rounded value is. So I'm going to pick up my calculator, put in 50 times the tangent of 58. Now, this problem doesn't tell me how to round. So when I'm not told how to round side lengths, I round those to the nearest hundredth place. So I have 80.0, the next digit is a 1, but the one after that is a 6, so it's going to bump the 1 up to a 2, and I'm working in feet. So again, I want to see, like on homework, first the rounded value, first the exact value, and then the rounded value. So in the next couple problems we're going to take a look at, we do not have a diagram drawn for us. So I'm going to read the word problem over and then draw a picture. So it says a pilot is looking at an airport from a plane whose altitude is 10,000 feet. If the angle of depression from the plane is 29 degrees, approximately how far is the plane from the airport? Round your answer to the nearest tenth of a foot. So I have an angle of depression. So I have something or someone up high looking down at something else. So in this problem, we have a pilot looking down at an airport. Now, angles of depression, remember, are drawn down from a horizontal. So I'm going to label this angle 29 degrees. And then in order to set up trig ratios, we're going to need a triangle. So I'm going to finish up drawing that triangle here. It says that a pilot is looking at an airport from a plane whose altitude is 10,000 feet. When we think about altitude, altitude is the same thing as height or a vertical distance. So this segment, this vertical segment up and down, is going to be 10,000. Now, you could also draw your triangle kind of on the bottom side here. Like if you wanted to think about the altitude from the pilot directly below to the ground to be 10,000, you could. This would be 10,000, same as this. And in the first slide, we talked about how angles of depression and angles of elevation are congruent. So this would actually be 29 degrees as well. So there could be a couple different ways that, really just like two ways, that you draw your picture and you look at a right triangle. So you could look at this one that kind of looks like it's upside down, or this one to the bottom corner that looks like it's right side up. Now, it says approximately how far is the plane from the airport? So we would have to think, if that plane were to travel from its position to the airport, what length or what segment would it be traveling across? So if the pilot and the plane were just going to go straight to the airport, they would be going down along this diagonal segment. And that is what I'm looking to find. So I need to set up a trig ratio. So what I'm going to do is I'm going to use the original triangle I drew. This one I'm going to just darken a little. And that's just going to help me kind of not have to look at so many segments and things. So relative to this 29 degree angle, the acute angle that I was given, what is 10,000? Is it the adjacent leg, the opposite leg, or the hypotenuse of this triangle? Well, 10,000 is the leg across, so this would be the opposite leg. In relation to the 29 degrees, what is x? What is the length I want to find? Is x the adjacent leg, the opposite leg, or the hypotenuse of the right triangle? Well, it's across from the right angle, so it would be the hypotenuse. If we use SOHCAHTOA, which trig ratio has opposite and hypotenuse in it? It's sine. So I'm going to set up the sine of the acute angle. Sine is equal to the opposite leg length over the hypotenuse. Once I set up my proportion, I'm going to go ahead and cross multiply. So one cross product, I get 10,000. Another cross product, I get x times the sine of 29. I'm multiplying x by the sine, so division undoes multiplication. So the exact value of x is 10,000 divided by the sine of 29. I'm going to go ahead and take my calculator. Type in 10,000 divided by the sine of 29. I'm gonna copy down the answer. Now this does tell me how to round. It says to the nearest tenth of a foot. So what's coming out of the calculator is 20,626 point, and I want to round to the nearest tenth. So I have a 6 and then a 5, so it's gonna bump up the 6 to a 7. And this is gonna be in feet. So the last one says, you are flying a kite with 20 feet of string extended. The angle of elevation from the spool to the kite is 41 degrees. How far off the ground is the kite if you hold the spool 4.5 feet off the ground? Round your answer to the nearest hundredth of a foot. So we're standing here with a spool of string in our hand, and we've let 20 feet of string go. So we have the kite up here in the air. The angle of elevation from the spool to the kite, remember angles of elevation are drawn with a horizontal, so I need a horizontal segment. That's 41 degrees. I'm just going to draw one more segment to close up that right triangle. And it says how far off the ground, so the ground's down here, how far off the ground is the kite? If we're holding the spool 4.5 feet off the ground, so the distance between the spool and the ground is 4.5 feet. So this triangle that I've drawn is set 4.5 feet off the ground. So I want to find the kite's height off the ground. So if I find X, which is this distance in the triangle, and then I add 4.5 feet to it, I will get the entire distance that the kite is off the ground. So my first goal is to find X. So if I look at the acute angle that I'm given in this right triangle, and I look at the length that I'm given relative to the 41 degree angle, what is this 20 feet? Is this the opposite leg? Is it the adjacent leg? Or is it the hypotenuse of the right triangle? It's across from the right angle, so it's the hypotenuse. What is X? The length I want to find. Is it the opposite leg, the adjacent leg, or the hypotenuse? It's the leg across from the 41 degree angle. So it's opposite. Like in the last problem, the sine ratio involves opposite leg and the hypotenuse of the right triangle. So I'm going to set up the sine of the acute angle. Sine is equal to the opposite leg over the hypotenuse. Once I set up that proportion, I'm ready to go ahead and cross multiply. One cross product gives me X. The other cross product gives me 20 times the sine of 41. There's my exact answer. The last thing to do is just pick up my calculator. Type in 20 times the sine of 41 degrees, and I get 13 point. This one does tell me to round to the nearest hundredth. So I have a 1 in the tens place, a 2 in the hundredths. The digit after that is a 1, so the hundredth place will remain a 2. And this is in feet as well.